come to the standard of complex mathematics, whereby the function is represented by f of z. Today's focus is residue at multiple poles. Remember, a pole is a point where the function is not defined. So suppose f of z is defined everywhere except at z is equal to alpha, whereby here it is the pole is on the n. Then to get the residue, R standing for the residue will be given by limit of limit n minus 1 factorial, limit as z tend to alpha of this derivative minus 1 over z minus 1 of z function of f of z. That is how we obtain the residue. In the case now, n is equal to 1. If n is equal to 1, then it means that our residue will be given by limit as z tend to alpha of d power 0 of z power 0 z minus alpha of power 0 f of z I mean power n f of z, which is equal to the same as limit as z tends to alpha of z minus alpha f of z. So that is how we get the residue in the case z is equal to, in case n is equal to 1. What about if n is equal to 2? If n is equal to 2, then residue of r of 2 will be given by limit as z tends to alpha of dz z minus alpha power 2 f of z. Also, if n is equal to 2, then r of 3 will be given by limit. Here we will have 1 over 2 factorial as z tend to alpha. This is alpha. Second derivative of z of alpha cubic. Second derivative of that f of z. That is what you do. Then if n is equal to this is 3. If n is equal to 4, then it follows that residue of 4 will be given by 1 over 3 factorial limit as z tends to alpha, then the derivative with respect to z power 3 z minus alpha power 4, then you multiply by the function. So today we have considered the general case on how to get the residue at multiple poles. And the general formula is this one, which I have given us here. The one which is given here is the general formula of obtaining the residue, which is given by limit. Remember, this formula can be reduced as follows. So residue is given by 1 over n minus 1 factorial limit as z tends to alpha, then d power n derivative divided by d divided by z power n minus 1 z minus alpha power n, then you multiply by f of z. That is the general formula for obtaining the residue. This one, residue is given by 1 over n minus 1 factorial limit as z tend to alpha d power n minus 1 divided by dz minus 1 of z minus alpha power n of f of z. Remember, the residue is found when you have a pole. A pole, and we have seen the pole is a point where the function is not defined. And we have obtained that